Okay, hi, and welcome back to my lab. So today I'm going to cover a little. Let me just show you the topic first. These are the topics that I'm going to cover for today. So we're going to cover AI-generated malware implant. Of course, I wouldn't be deep diving too much into how I generated the malware implant. Okay, but I'm just going to explain to you roughly how it works. So the implant features and how this thing actually we'll touch a little bit about how it remains stealthy within the PE Studio or PE Bear, okay, which are tools which are used that are used by investigators, forensics investigators to actually look at malware. And then I'll talk a little bit about the lab diagram, and we'll talk about how we use STunnel and Netcat NC on Kali to be able to get the callback. Okay, so this malware is going to be a very simple malware that basically what it does is it makes a callback over to the Netcat listener, and once that is established, it will basically it will display a command CMD shell, okay, a reverse shell for this. Executing implant on Windows 11 plus Symantec Endpoint Protection. So we'll show you how this implant can bypass Symantec Endpoint Protection, as well as executing the implant on Windows 11 with Comodo Antivirus. Comodo Antivirus is just kind of like something that's a little bit additional because I was looking for something that is free and possibly something that's a little bit stronger, something that's a little bit stronger than Symantec Endpoint Protection, or a little bit more verbose at least, you know. Not to say that Symantec Endpoint Protection isn't that strong, but it's just that Comodo Antivirus is a little bit more verbose. It actually prompts you and says that, hey, you're going to execute something, and do you want to allow, accept or deny, right? Okay, so yeah, and I'm going to run Wireshark as well as one of the queries in order filters in order to be able to see and observe the TLS traffic. Okay, so let me just go straight into the diagram. So the diagram looks something like this. Okay, we have a Windows PC with a Symantec Endpoint Protection, and we have a Windows PC with Comodo Antivirus. The C2.exe implant, this is compiled within, this is using Go, okay, the Golang compiler. So I compiled it, the code is written in Go, generated in Go, and I compiled it using the Golang compiler. And basically what it does is it makes a callback to my Kali box on 10.10.10 222. Okay, 10.10.10.222, port 443 over TLS. Okay, now this is a little bit interesting because when we talk about having callbacks made to, if you do the callback in raw TCP, what happens is that if you have things like parameter firewalls with IPS, IDS, you know, or even host-based kind of IPS-like kind of functions within the antivirus, it will be able to look at this kind of traffic and realize that this is malicious and it will block the traffic. So because of that, the implant actually makes a connection over to, it uses the TLS library and it establishes a TLS tunnel with the STunnel listener on port 443 on the Kali box. Okay, and the STunnel listener redirects from port 443. It removes the TLS encapsulation and it redirects in raw TCP mode into port 4433, which is my actual Netcat listener. Okay, and let me just dive straight into it to show you how it works. Okay, so I'm on my Kali box. We're going to do a S-tunnel. Now, before we do this S-tunnel thing, probably we're going to do like maybe like cat S-tunnel first, just to show you the configuration file for S-tunnel. Okay, and then we're going to run the S-tunnel. It goes ahead and runs in the background, so you won't see it. Okay, so right now it's going to redirect to my Netcat listener. Next thing we're going to do is we're going to set up the Netcat listener. So I'm going to do a sudo nc lmvp 4433. Okay, so right now it's listening on 4433. This is for raw TCP. Okay, and okay, so we're going to go to the Windows machine first. Over here I have my Symantec, and you can see that the updates are all, there's no new updates. So this is the latest virus definitions. Okay, and basically, Symantec, you can see that even the thing that prevents this kind of callback is actually located within the network and host exploitation mitigation. If you look at it under the intrusion prevention, enable network intrusion prevention. This is the thing that prevents the callback to be done to a C2 server. Okay, so this actually looks for behavior that is like that, and it blocks it from there. But you can see that no, we're going to bypass this. Okay. Now I just minimize the antivirus. Uh, I have my Wireshark filter that's already set up over here. Let me just run my Codium, and yeah, so this is what we're going to look at. Okay, I may need to modify the port a little bit because the IP address might have changed. So it's 101. So we're going to sniff from 101 to we're going to change this to 101. Okay, and we're going to sniff. We're going to filter by source coming from 101 to destination, which is .222. Okay, and the destination port is going to be 443, and protocol will be TLS. Let me just fire up Wireshark. So it takes some time to open, and I believe this will be Ethernet 0. Yep, it is Ethernet 0, and I'm going to just kind of like apply the filter. Okay, so once we apply the filter, it wouldn't show anything until something is triggered. Okay, and we just double click the c2.exe and see what happens. Okay, so right now this is what we're looking at. This is the listener on the netcat, listener on Kali, and we're just going to double click the c2.exe. Okay, and it should show up in a while. And yep, we have it. Okay, so you can see that I've successfully gotten a reverse shell on the Windows machine. Okay, and as you can see that I purposely make sure that this window isn't hidden. It is because this implant is meant to be used for like testing security, red teaming purpose, legit red teaming purpose, or pen testing or whatever. So I do not want this window to disappear and go away. I do not want it to be a stealth window. I want it to be, I go to a machine, I execute this, it will make a callback to my STunnel, and then STunnel will redirect over to the in raw TCP over to the netcat listener. Okay, so yeah, if I close this window, obviously it will close the session as well. Okay, and if we go to netcat, we can just see that there's a whole bunch of TLS 1.3 traffic that's going through. Obviously, it's encrypted, so we won't be able to see anything. But this is just to confirm that we are making a connection from our Windows machine on 101 to 222. Okay, on port 443 over TLS. Okay. Yep, so you can see that this is totally stealth. I'm going to do a Control-C to break the session, clear the screen, and I'm going to rerun it again. Now notice that you only need to rerun the netcat listener, but you do not need to rerun the STunnel listener. The STunnel listener is always on all the time. It's like a service running in the background. Okay, so the only thing I need to restart is the netcat listener. Yeah, so I'm going to switch over to another virtual machine, also running Windows 11, and this one has a Comodo Antivirus. Okay, so Comodo Antivirus is a little bit different because what it does is a little bit more verbose. Again, because I accepted this before, so it may not prompt for accept or deny. But however, if this is the first time you're running an exe file or any kind of like maybe even an Office document or something like that, it will prompt you and say that do you wish to open the file? No, accept or deny. It does add an additional layer of prompt, okay, just to make sure that you are, just to be certain that you indeed want to execute the file. And let's execute the file and see what happens. Okay. So you see, actually it prompts me, C2exe is trying to execute conhost.exe. Do you want to allow? Okay, so I'm just going to say, okay, let's take it as this part is maybe social engineered by the attacker, right? It tells the user to go ahead and allow it, and you open up the window and it does make the callback. It prompts you again, so I have to allow again. Okay, and it does give me a reverse shell as well. Okay, so it does work. I mean, it does work. However, it does require, possibly a little bit of social engineering, or something like that, some kind of social engineering, social manipulation, in order to get the target, the victim, to be able to execute this through a Comodo Antivirus desktop. Okay, and also for Comodo Antivirus, I'm just going to kill the session and restart the listener. Okay, for Comodo Antivirus, there's a little bit of a learning curve, even though it's kind of simple. It's a very simple antivirus. In fact, it looks simpler than Symantec Endpoint Protection. But there is a little bit of learning curve, in the sense that you need to teach the user to how to use it properly. So if we go to task, uh, there's a whole bunch of it here. We go to containment task. You can see that we can run virtual, or we can run virtual desktop. Okay, so basically what happens that if you select, sorry, let me turn on, okay, my listener is listening to it. If you select run virtual, what it does is that it does some kind like a sandbox, or rather the word they use here is containment. So it's something like a Windows-based container. It's like a container overlay on top of your Windows operating system. Okay, so if you run it in virtual, okay, if you run virtual within a container itself, um, and if you run it virtual, okay, it will still go through, and it will still establish a reverse shell, as you can see. Okay, it can still have a reverse shell as well. Okay. However, the great thing about virtual is that no, you can kind of like, okay, even let's say if this is not there, if let's say the user is done with this session, and they decide to, hey, let's clear the container. If they reset the container, okay, and they erase the changes, it will it basically breaks the session. Okay, it disconnects the session and it clears everything. There won't be any kind of like artifacts remaining on the machine, because it creates a container overlay. Okay, so it prevents the malware from really infecting your machine. So there'll be, basically, it's difficult to maintain persistence on a machine that is running Comodo Antivirus. So just for the record, I'm not sponsored by Symantec. Neither am I sponsored by Comodo Antivirus. I'm just doing a simple presentation to talk about certain points about how we can bypass antivirus. Okay, yeah, and the other one we can do is we can run the virtual desktop as well. Now I realize that I'm actually not going in order of what I'm supposed to be showing, but it's okay. We'll get back to it in a while. I would like to talk about the implant features, as well as the PE Studio and PE Bear. So okay, we can also run the virtual desktop. Okay, and when the virtual desktop kind of loads, what it does is that it overlays on your physical desktop. Okay, and if you double click on the C2 implant, oops, sorry, let me let me restart the listener. Okay, and let me just double click on the C2 implant. And you can see that there is a reverse shell. Okay. However, likewise, if you exit from the virtual desktop, okay, the moment you exit from virtual desktop, it disconnects the session. Okay, so it's very difficult to gain if your users are trained to you. Okay, if your company is using, if your organization is using Comodo Antivirus, and you train your users to use it in a correct way, which means that if they get any kind of like attachments or downloads from the internet, okay, and instead of just going ahead to run those files, be it an Office document or PDF file or an exe file or whatever, or any kind of script, if they run it through virtual, or they run it through the virtual desktop, it prevents them from it prevents it from the malware from creating any form of persistence within the Windows operating system. Okay, so it does require a little bit of training on the user end to teach them how to use it in a correct fashion. Okay, yeah. So that's about it for for the malware. I'm going to just talk a little bit about yeah, the implant features. So let me just let me see. Let me see if I can get this on my the implant features. Aha, C2 Go. Okay, let me just open this up. Okay, so I've sort of redacted the code because I don't want people to be using this code. How I got this code is through a series of, or rather a process of using multiple LLM models, where I use it to craft certain prompts to be able to generate the code. Okay, and then of course I run it through a commercial kind of AI, okay, like Copilot or OpenAI as well. The thing to understand about commercial AI, commercial kind of AI platforms, whether it's Copilot or whether it's OpenAI or even for DeepSeek as well, is that many of these platforms, they come with very strict guardrails, and the guardrails prevent you from creating prompts that you can't just type something, like you can't just prompt it and say, generate malware for me in C++, generate malware for me in Golang or in Python. No, it will not work. Okay, they will flat out say that this is illegal. We do not condone such activities. Blah blah blah. Whatever. It will just it just shut you down. Okay, so there are other ways to get around this. To use LM models which are not censored, models which allow you to ask such questions. However, you do have to go through not just those models, but you have to go through, you have to use not just the uncensored models to generate it, but you also need to go through commercial AI in order to get that kind of quality to be able to create malware that is able to bypass protection mechanisms. Okay, so in this case, some of the features we have is basically the TLS encryption that we use. Okay, you can see that it uses the crypto TLS library for Go. Okay, the import crypto TLS library. We have a little bit of obfuscation. This is more for preventing, like I said, tools like a PBear or PStudio from flagging out, that this is a malicious exe file. So basically, we use a XOR, XOR, not XOR. I always say XOR. It's actually XOR. Okay, it's the XOR operator. So we use the XOR operator as well as the base64 encoding to change the IP address. Okay, instead of storing this string in clear text, it encodes it into something that PStudio or PBear won't be able to recognize. Okay, so this makes it even more stealthy, so that the tools like PBear or PStudio will not be able to pick it up so easily. Yeah, and over here you can see that these are the decode functions, okay, to decode it back into the actual IP address and the port number. Okay, so it's pretty simple. It's not that complex. Pretty simple as well. Okay, of course there's a few other features which I kind of doubt whether they're really useful, like sandbox evasion. This was generated by AI, by the way, so I kind of like doubt whether this is really useful. Okay, because basically it only detects like VirtualBox and Python environments. So I may need to do a little bit more research into generating code that can detect if it's going to run on VMware and fail to execute. Yeah, because VMware is a little bit different, right? So different hypervisors have a different kind of environments, and you need different ways of detecting it. And the other one is the random execution delay. Okay, this one is simple to avoid detection in sandboxes. Reverse shell, the one you just saw with cmd.exe, is piped through a TLS connection. Okay, so these are basically the features of this malware. Yeah, so today's video is just to prove a point that just to prove a point that it is possible to bypass commercial antivirus. Okay, and yeah, basically this malware, this C2, I mean, I wouldn't really call it C2 because it's kind of like a C2-like kind of implant, can bypass such antivirus. Okay, and I hope you enjoyed this video, and yeah, thank you for your time.